Now on down to number 25. Looks like I have just a single decimal, so that means I'm going to be multiplying by 10 on both sides of the equation. However, I have a quadratic, and this is on the right side, so I need to get that over to the left side. That's the first thing that sort of bugs me about this question. Okay, I want to make sure that it looks like a quadratic that says ax squared plus bx plus c equals 0. So negative 0.5x squared plus 1.2x minus 0.4 equals 0. And here's another problem, is that when people subtract that 0.4, they don't want to write equals 0. You have to write equals 0 there. Okay, so now our issue is that we have decimals. So what I'm going to do is take a different color. I'm going to be multiplying by 10 on both sides. Okay. And this trick actually, it doesn't just work with the number 10. For example, if I had 5 over 2 plus 7 over 2 minus 9 over 2, I could multiply both sides by 2. Okay, you can do whatever you want to both sides of the equation just as long as you do it correctly. In other words, you have to do the entire side. You have to be multiplying this entire side by 10. Okay, so here we go. That gives me negative 5x squared plus 12x minus 4 equals 0. And now what you're going to do is get rid of that negative. Remember, I don't like negatives at the very beginning. So I'm going to divide by negative 1. So now I have positive 5x squared minus 12x plus 4 equals 0. Okay. So we're going to continue to work there. Let me see. There's not a greatest common factor, so the only option here is to do the Lizzie method again. Lizzie, 5 times 4 gives me 20. X squared minus 12x plus 20 equals 0. Now, if it so what multiplies up to 20 adds up to negative 12. Oh, my lead's coming out here. I have to use another pencil. Okay, so what multiplies up to 20 adds up to 12? Well, let's think about it. Multiplies up to 20. I've thought so far what went through my head was 5 and 4. But I don't think that adds up to 12. And then I thought, does 6 go into it? Well, no, 6 doesn't go into it. And then I thought 10 and 2. 10 and 2 has some chance to adding up to negative 12. So if they were both positive, they would add up to positive 12. If they're both negative, they'd add up to negative 12. So let's try that. Negative 10. Negative 2. Negative 10 times negative 2 multiplies up to positive 20. So so this is the correct factorization of it. Now from here though, since we already multiplied by the 5, we need to divide by 5. So we're dividing by 5, dividing by 5. Remember, if you can reduce the fraction, please reduce. If you cannot, you move the 5 out front, in front of the x. Not in front of the parentheses, but in front of the x. I'm going to erase my work over here to save me a little bit of room. So here we go. X minus 2 times 5x minus 2 equals 0. So this step goes to this step. And now I have two values multiplied by each other equals 0. So a equals 0, or x minus 2 equals 0. And 5x minus 2 equals 0. So on this one, all I have to do is add 2 on both sides, and I get x equals 2. However, I have a couple of steps for this. I have to add 2, 5x equals 2, then I'm going to divide by 5. So x equals 2 over 5. Okay? So hopefully that helps you out on the first, or 22, 23, and 25. Let's do 26 and 27. The first thing that I noticed about 26 is that it doesn't look like a typical quadratic, and if I can get it to look closer to a typical quadratic, then I can solve it. But it just doesn't look right now. So what I'm going to do is I'm just going to distribute 1.2 p squared plus 1.2 equals 2.5 p. This still doesn't look right because I need an a, b, and a c value. So I need ax squared plus bx plus c. So what I'm going to do is I'm going to subtract this 2.5 p on both sides. This gives me 1.2 p squared minus 2.5 p plus 1.2 equals 0. Alright? So now, can I multiply by a power of 10 to make it look like a quadratic that's easier to solve? Absolutely. Multiply by 10 on the left side and the right side. Remember, when you multiply by something, you have to multiply every term in here. There are 3 terms. Okay, so this is 12p squared minus 25p plus 12 equals 0. And notice again that there is no greatest common factor. This actually becomes a Lizzie problem again. So 12 times 12 is 144. What multiplies up to 144 and differs by 25? What multiplies up to 144 and differs by 25? I don't really know. Okay, so what I'm going to do is I'm going to pick 2 numbers that differ by 25. I'm going to pick 5 and let's say 30. Well, if I pick 5, then it has to be 30, right? 5 and 30. That's 150. So I'm actually kind of close. So let's pick 4 and 29. That's 116. So what I've just learned is that, let me see, they both have to have the same sign. So they're either both positive or they're both negative. I'm trying to see if maybe I copied the question down wrong. And I don't think I did. So let's think of the factors of 144. 144 divided by 2. 72 and 2. There's not a chance for that to add up to 25. So 144 divided by 4. 4 and 36. That doesn't add up to 25. 144 divided by 16 maybe. How about 16 and 9? I didn't even try that. 16 and 9. Do they differ by 5? Or 25? No, but if I had positive 16 and negative 9, that differs by 25. So that's the deal there. They have to have different signs. 16 and 9. So p minus 16, p minus 9. Did I say they have to have different signs? I'm sorry. I was thinking the difference has to be 25. That's not true. Their sum has to be 25. So that's my fault on how I was